Hello, in this episode we're going to be generating a road mesh along a path. The process we'll use is very simple. Starting with our path, we generate evenly spaced points using the method from last episode. We then calculate the direction from the first point to the second point, and perpendicular to that we place our first two vertices. For the next point we have two directions we could use, the direction coming from the previous point and the direction going towards the next point. For the nicest result, we'll just take the average of these two and place two more vertices perpendicular to that. For the last point, we have just one direction we can use, and so our final two vertices will be perpendicular to that. We now just need to connect these vertices to form triangles. For example, vertices 0, 2, 1 could form the first triangle, the only reason for that order being that the triangle should be wound clockwise in order to face the correct way. So the second triangle could be 1, 2, 3, followed by 2, 4, 3, and finally 3, 4, 5. Also quickly note, by the way, that the number of vertices we have is equal to 2n, where n is just the number of points we generated along the curve, so in this case 3, and the number of triangles is just 2 times n minus 1. Okay, so inside the examples folder, I'm going to create a new C# script called road creator, and I'll open that up. In here I'll create a method which returns a mesh called createRoadMesh, and this will just take in an array of vector2s for the points along the path. We can start by creating an array of vector3s to hold the vertices. So the size of this will just be the number of points multiplied by 2, as we saw a moment ago. Then we'll need an int array for holding the triangle data, so set this equal to a new int array. And we saw that the number of triangles is equal to 2 times the number of points minus 1. And then, since there are 3 vertices in each triangle, we'll need to multiply that by 3 for the size of the array. Okay, let's now create an int vertex index, starts at 0, and triangle index starts at 0 as well. Let's now loop through all of the points, so for int I equals 0, I less than points.length, I plus plus. And now for each point we want to get its forward direction, so I'll create a vector2 forward and just set this equal to vector2.0. So as long as we're not currently on the last point, so I can express that as if I is less than points.length minus 1, as long as it's not the last point, then we can set forward equal to the direction to the next point, so points with an index of I plus 1, coming from the current point. Similarly, as long as this is not the first point, so if I is greater than 0, then we could set forward equal to the direction to the current point, coming from the previous point, so points with an index of I minus 1. Now, if it's not the last point and it's not the first point, then I actually want the forward direction to be an average between these two. So instead of just assigning it directly to forward, I'll say forward plus equals these two things. And then at the end, we can just normalize the forward vector like so. Okay, so if you imagine this red line is our forward vector, we can easily get our left vector by swapping the x and y components, and then multiplying the new x component by -1. Okay, so I can now create vector2 left equal to a new vector2 with its x component being negative forward.y and its y component being forward.x. Alright, I'm quickly going to create a public float up at the top here for the road width. I'll set that equal to 1 by default. And then we can add our two vertices. So verts with an index of vertindex is going to be equal to the current point, so points I, plus left multiplied by road width multiplied by a half. And then the next vertex, so verts with an index of vertindex plus 1, is going to be equal to the current point minus left multiplied by road width multiplied by a half, and then we just increase vertindex by 2. Alright, now just before we increment the vertindex, I want to add in the two triangles. So coming back to this diagram, say we're currently on this first point over here, so we will have just added in this vertex to the left and this other vertex to the negative left, also fondly known as the right. Let's call the index of this first vertex v, then this will be v plus 1, up here we'll have v plus 2, and v plus 3, and so on. So in general terms, our first triangle goes from the current vertex index to vertex index plus 2, to vertex index plus 1, and the second triangle goes from vertex index plus 1 to vertex index plus 2 to vertex index plus 3. Note, of course, that when we get to this last point, there are no more triangles to add in, unless it is a closed path, which we'll worry about a little bit later. So back in the script, we can say as long as this isn't the last point in the path, so if I is less than points.length minus 1, then we can say triangles with an index of triangle index is equal to the vertex index. And I'm just going to copy this twice for the remaining two vertices in the first triangle. So this will be with an index of triindex plus 1, and the second will be triindex plus 2. And these will be equal to vertindex plus 2, and then vertindex plus 1. I'll then copy all of these for the second triangle. So these will have indices plus 3, plus 4, and plus 5, with vertex indices going v1, v2, and finally v3. At the end of this, we increment the vertex index by 2, and increment the triangle index by 6. Now that we've finished calculating our vertex and triangle data, we can construct a mesh. So I'll say mesh is equal to a new mesh, and then I'll set mesh.vertices equal to the verts array, and mesh.triangles equal to the triangles array, and then just return that mesh. Alright, back up at the top, let me create a public float spacing. I'll set that equal to, say, 1, and I'm going to make this a slider, so I'll have this in a range between maybe 0.05 and like 1.5. I'm then going to create a public method called something like updateRoad, and this will start by getting a path. So get component path creator and grab the path from that, and then I'm going to get a vector2 array of points is equal to path.calculate evenly spaced points, passing in the spacing value, and then I'm going to get the mesh filter component and set its mesh equal to the result of createRoad mesh, passing in the points. Now, currently we're just assuming that whatever object this road creator is attached to also has a path creator and a mesh filter attached, but let's be a little bit more rigorous and add a require component attribute up here. So this will be type of path creator, and then I'll copy that, require a mesh filter as well, and also a mesh renderer, since the mesh filter doesn't really make sense without one. Alright, now we obviously need to call this updateRoad method from somewhere if we ever want to see the road. So for testing, I'm going to create a public bool auto-update, and when that's true, I want updateRoad to be called from an editor script whenever the scene gets repainted. So I'm going to save this, go into Unity, and when that compiles, go into the editor folder and just create a new script called road editor. And in here, I'm going to add the Unity editor namespace, inherit from editor, and this will be a custom editor, type of road creator. I'll create a road creator variable called creator, and I'll assign that in the onEnable method. So I'll just say creator is equal to the target, but cast as a road creator, like so. And then on scene GUI, we can say if the creator wants to be auto-updated, and the current event type is equal to a repaint event. Then we'll just call creator.updateRoad. I'll save that, go into Unity, and create a new empty object. Just reset the transform so it's at 0, 0, 0. And I'll add a road creator component to that. And going to turn on auto update and just reduce the spacing a little bit and maybe decrease the road width as well. So can now move the path around and the road updates. One problem might be if we try and insert a point, you can see it actually deselects the object because it's trying to select the mesh behind it. So we'll have to make a small modification to the path editor script, just coming down to the bottom of the input method. I'm going to say handle utility dot add default control and pass in a control ID of 0. So this just means that if nothing else is selected, then this invisible default control will be selected, and that will prevent any stuff in the background, like the mesh, from picking up the selection. Alright, so I'll save that. And now, once that compiles, should be able to insert points without a problem. To make it a little easier to see what's going on, I'm just going to turn off display control points and turn on auto set control points, so that I'm just dealing with these main points here. Alright, this is looking good. Just one thing is, of course, if we try and make the path closed, then you can see it doesn't exactly join up at the end. So we're going to want to bridge this gap by adding in 2 new triangles between the first and last 2 vertices for a closed path. So let's go into the road creator, and I'm going to add a new parameter to the createRoadMesh method here. This will be a bool isClosed, and when we call it, we can pass in path.isClosed. And so if we calculate the number of triangles, this will be equal to 2 times the number of points minus 1. But then if it is a closed path, we'll want to add 2 onto that number. Alright, we can then set the size of our triangles array equal to the number of triangles multiplied by 3. Coming down to where we're actually adding the triangles, if it's a closed path, then we do want to add triangles for the very last point. So we can say OR is closed, but now these vertex indices, which are +2 and +3, are going to be out of range of the vertex array. We just need to loop them back around. So I'm going to put these inside parentheses and then say mod vertices.length. Okay, let me copy that, and I'll be doing that for this one here as well, and the +3 one. Now for a closed path, of course, the last point does actually have a next point, since that will just be the first point then. So let's say OR is a closed path, and we can just wrap this around by saying mod points.length. And similarly for this one here, we can say OR is a closed path. Then we'll wrap this around, mod points.length. But we have to be a bit careful because negative numbers won't get wrapped around in C#. So we'll just want to add points.length to that to make sure it's always positive. Okay, so that should work. Let's save, go into Unity, and once that compiles, you can see the gap there has been bridged. So we've now got a nice closed path, and if I toggle off the closed, then the open path is still working properly. Now it would be very nice if we could apply a texture to the road, so we're going to need to give it UV coordinates. So let's go into the road creator script, and below the vertices array, we'll create a vector2 array, UVs, and this will just need the same length as the vertices array, so just say verts.length. And then over here where we're setting the vertices, let's start by calculating how far along the path we are. So I'll call this the completion percent. And it's going to just be equal to I divided by, and cast to a float, the number of points minus 1. So it'll be 0 at the start of the path and 1 at the end of the path. We can then say UVs with an index of the current vertex index is equal to a new vector to 0, completion percent, and UVs vertex index plus 1 equal to a new vector to 1, completion percent. So just to be sure that's clear, this vertex over here would have a UV coordinate of 0, 0, meaning the bottom left of the texture. This one would be 1, 0, so reading from the bottom right of the texture. Then up here would be 0, 0.5, middle left of the texture, 1, 0.5, middle right of the texture, and then 0, 1, top left of the texture, and 1, 1, top right of the texture. Alright, so I'll save that. Actually, 1 second, we actually need to apply that to the mesh. So mesh.uv is equal to the UVs. Okay, save, go into Unity, and I'm quickly going to import this simple little track texture I have. Going to drag that in there, and I'll create a material as well. Call this road. I'll just make this a unlit texture, apply the road texture to that, and I'll drag that onto the road. Okay, so we can now use the tiling property on the material to repeat this a bunch of times vertically. It's currently not actually repeating though, and that's just because of the wrap mode on the texture. We need to change this from clamp to repeat, and now you can see it actually repeating. So you can make that repeat a bunch of times, and that's looking very nice and roady. There is one problem though, which is if I make this into a closed path, okay, it's not actually visible here, but let me just deselect this so you can see properly. There are some strange artifacts at the end here, and the reason for these is that at the beginning of the road, our completion percent is 0, and remember that's the vertical component of the UVs. Then as we go around, it increases all the way up to 1, and so it's 1 at the end here. But then on these last two triangles that are sort of bridging the gap between the start and end of the path, the UVs quickly go from 1 at the end of the path to 0 at the start of the path. So it's mushing the entire tiled texture into that space. Now, there are a couple of ways we can fix this, but I think the easiest is instead of going from 0 to 1 around the path, it should instead go from 0 to 1 somewhere in the middle, back to 0 at the end. That way the end and the start have the same value. So we're going to need a function that takes an input between 0 and 1 and returns an output that moves linearly from 0 to 1 back to 0 again. So we can use the function 1 minus the absolute value of 2x minus 1. So going into the script, I'll say float v is equal to 1 minus the absolute value of 2 times completion percent minus 1. And then just use this value v in both cases here. Alright, so if I save that, wait for that to compile. If I just click on something to force it to update, we should see that problem go away. Cool, so the last thing I'd like to do in this episode is just make it so that the tiling resizes automatically based on the length of the road. You can see if I have a small road, then it's all bunched up and deformed, and if I have, say, a really long road, then these get really long. So they should basically maintain a constant size as we resize the road. So coming into the road creator script, I will create a public float tiling, set that equal to 1, and in the update road method, I'm going to say int texture repeat is equal to mathf.roundToInt of the tiling value multiplied by the number of points in the path, so points.length, multiplied by the spacing, and finally multiplied by some small constant factor like 0.5. We then just have to get the mesh renderer component so that we can grab the shared material and set its main texture scale equal to a new vector 2, 1, texture repeat. Okay, so save that, go into Unity, wait for the compile to finish, and now we can just increase the tiling amount until some lines appear there. And if I extend the length of the road, those lines should remain roughly the same length, as well as if I increase or decrease the spacing, you can see those remain roughly the same. And now if I turn on closed path, this is all working as well. So that is everything for this episode. Until next time, cheers.